Okay, once we have established that we have a good probe compensation on the arm, we may want to do some basic probing. This example will illustrate no CAD. So to begin with, I am going to construct a plane line point alignment on a basic part and then measure 2 circles or several circles to construct a bolt circle pattern, and then maybe construct a quick distance just to give you an idea how to do some basic things here. To begin with, we're going to indicate in the feature selection toolbar over here that we want a plane. We'll just let it be of type empty feature for right now. We're just going to build kind of the architecture we want to work through. So we're going to do a plane, and we'll do a vector, and then we'll do a center circle as well. And for right now, we'll just select those items here and indicate that we want to probe those. So it's going to come up here, connected to the arm, so it's ready for us to shoot. So go ahead and probe the plane. A series of green button clicks on the surface, pull away from the surface, hit the red button, gives us a confirmation opportunity here where we can see the flatness is 13 microns, we're in metric. We'll hit the green button to confirm, and then we'll go ahead and probe a vector, and again confirm, and then we'll probe a circle. These 2D features, click all of those, pull to the middle, hit the red button, and say confirm. It's important to note that these 2D features, as I started saying a moment ago, utilize what is known as a plane of constraint. So if we click on vector 1, we can see that the constraining plane was plane 1, as we would expect and want. It's important, I guess, to say here that you should work in planar groups. So now we need to establish a coordinate system or an alignment. Typically when not using CAD, I just do a coordinate system. So now let's say, okay, primary feature for alignment of this coordinate system will be the plane. I want it to sit on the plane first and foremost. Within that plane, we'll clock it to vector 1, paying attention to the vector's direction based on the way I probed the first 2 points when I probed that line, and then the circle. And then what we can do is actually specify the circle before the vector and have it lock in as such. And then if we want to change the assignment of the directions and or XYZ, we can click on these little arrows to kind of rotate things around. Once we have it the way we want, we're going to say create, and we can allow it to set it as active if we want. Then we'll close, and we see that now the world has gone gray. This one has gone colorful, indicating that it is active and current. And if we look at a feature like circle 1, we can see that the X, Y, and Z values are exactly perfect as we would expect, because that's the way that we set up the coordinate system. Okay, so now that we have that coordinate system, we'll continue through with our workflow. Once again, we're going to say circles. I may want to change the name of this initial circle here to be origin circle. So now I can do, let's say, 4 more circles like this. Highlight these 4 circles and then construct the bolt circle that runs through them all. And we would do that by saying circle 5 will be from object's center point. And we might call this the bolt circle. And we'll hit create. At this point we get a red chain link indicating that it's a dependent feature and actually not one that we would measure. We'll highlight these and then say probe measure. If I take a reading that ends up being a bad reading and I click the red button to accept it, and it throws the form out, it's going to warn me here. I can use the green button to toggle between these and hold down the green button on reprobe to initiate a remeasurement of, in this case, circle 3. If, like I just did on point 7, I know I took a bad reading, or maybe even 2, I can hold down the red button and it'll slowly pull back readings, and then I can continue onward and get a good result. Then from there, now that I satisfied all of the readings for these 4 circles, they're all measured, showing a green check mark. And then the bolt circle is showing a green check mark as well now because it was able to calculate. And so all I would need to do now is potentially go in and type in some values for these circles. So I can highlight these circles. Diameter should be 70 for all of them. And you see that, or excuse me, the diameter is 20. And then maybe we want to turn on the XY location as well. I won't bother typing in all those values. For the purposes of this example, I think you get the idea here. This guy is 140. If I wanted to do some GD&T, I could specify my datum, so I could go to plane 1 here and go to its properties and apply that. And then maybe vector 1 is actually datum B. I could apply that. And then maybe my center circle is actually datum C, and I could apply that. And now I could go to these 4 individual circles, and instead of looking at the dimensions, I can switch over to GD&T and say add, and transpose the control frame right from the print, whatever it might say. So A, then B, then C. And because C is a circle, I could even have bonus tolerance on that if I wanted to. And hit create. You see it calculates all the necessary information, including the mating diameter, which, you know, the mating diameter on all these guys really needs to be 20, so we can edit that as well. You see it's on the, it's looking pretty good. Adjust the mating diameter on that circle. And lastly, let's do a basic dimension. We can jump back into the dimensions toggle here on this radio button, and then perhaps we select circle 1 to 3, which will be from here to here. We could do a dimension. So we'll say, hey, we want a dimension. By having those pre-selected, it knows it should be them, adds it, establishes the 3D distance, and we can type in the value here. And if we want, we can turn on the componentized properties as well. The last thing that might remain is to get some things put into a report. So as we go through from the different view orientations, it's good to build the report as we go. There's 2 components for a report. There's either a screen capture of the canvas or a chart of the highlighted features. And for that purpose, I'll just highlight all of the features. Let's say the origin circle through the distance. And we'll say give me a chart there. And we're building those in here, they're dependent features, and we can say, hey, lay that out in the report for me automatically, and it lays it out. And those things that have been nominal and toleranced show up in green or red notation, and those things that are not yet nominal, because we have to type that in, are showing up white. And then here. So that concludes the no CAD probing workflow.